How about, let's talk about alternating series. If you noticed so far, one thing we've been looking at positive decreasing series. The terms are positive and terms are decreasing. Well, what happens if we come upon an alternating series? Well, turns out there's a test for it. Here it is. If your series is an alternating series, and so here we're specifying, we've got something. Now, this says -1 to the n. It doesn't have to be exactly that. I mean, we saw that sometimes it's -1 to the n plus 1 or n minus 1. But somehow we get this alternating series stuff involved, okay? So if that's what we've got, where the b sub n greater than 0, so b sub n is greater than 0 and satisfies the following criteria. Little I, number 1I, bn plus 1 is less than or equal to b sub n for all n's. What does that mean to you? Well, the b sub n part, then, this is saying the b sub n plus 1 is less than or equal to the b sub n's. What does that say? Well, the b sub n's are, without the alternating sign part of it, the b sub n's are decreasing, right? This part of it is decreasing. Basically, that's what that says. B sub n is a decreasing series. Not increasing. Number 2, then, the limit as n goes to infinity of the b sub n's is 0. If all that's true, then the series -1 to the n b sub n converges. So there's several parts to this one too. Okay? All right. Let's do one. Here is what I need to look at. Let's take a look at the one I start with is this series here. -1 to the n minus 1 over n. Now, pretty obvious here what test I want to use on this, right? That's an alternating series. And so it's pretty obvious for these. It's not hard to tell. That the alternating series test is the way to go. If you have an alternating series, you're probably going to use the alternating series test to tell whether it converges or diverges. Okay, now, the other part to this is the b sub n we're talking about for all these parts. The b sub n is just the part without the alternating sign part. So what is b sub n here? Well, think of that, break that out as, wouldn't it be -1 to the n minus 1 times 1 over n? And so that's my b sub n right there. The b sub n is 1 over n. Everybody okay with that? With me on that? Okay, so The B sub n's are greater than 0. Check. B sub n satisfied. All right, so there's two parts that we need to look at. Is B sub n plus 1 less than or equal to B sub n? That's the I part. Well, what would B over n plus 1 be? Well, that just means plug in n plus 1 here. So that would be 1 over n plus 1. B sub n is just 1 over n. Can we say with our little surety there, that's true? Is that less? 1 over n plus 1, is that less than 1 over n? Yeah, because you got a bigger denominator. 1 divided by a bigger denominator is going to be 1 over, bigger than that 1 over n. That's true. Check. Okay, number 2. The limit of the B sub n's. Does that equal 0? Well, that would be the limit. In this case, n goes to infinity of 1 over n. That's easy. What is the limit as n goes to infinity of 1 over n? That's 0. Okay. Check. Check, check. Check, check, check. Okay. So this series converges. So both of those are true. This series converges. Both of those are true, so this series converges by alternating series test. It's always a good, I forgot to keep putting that, but it's always good to tell me what test you're using right there so I'll know if it's not entirely clear what you're trying to use there. But yeah, by alternating series test, this series converges. Okay? Now, let's think about that little series right there a little bit more. Do you notice this series is the counterpart to the harmonic series? The harmonic series. Well, that's just the series 1 over n. What about the harmonic series? Divergent or convergent? Divergent. Isn't this the alternating counterpart to harmonic series? Yes. But what about this? Convergent or divergent? Convergent. So the harmonic series diverges, but its alternating series counterpart converges. Kind of an interesting little note there, isn't it? So it kind of flips over to the good side, I guess we might say. But anyway, just an interesting note. All right, here's another. What about the series negative 1 to the n times 3n over 4n minus 1? Again, it's an alternating series, so alternating series test obviously is our choice, first choice. What is B sub n in this case? Well, B sub n would just be 3n over 4n minus 1. Well, that is our first thought there, but let's skip ahead here to part 2. Part 2 says, let's look at the limit of my B sub n's. What do you got there? Well, divide by n on top and bottom, you have then go to infinity, 3 over 4 minus 1 over n, that's 3/4. We have a problem. Why do we have a problem? Because part 2 of the alternating series test is the limit of the B sub n's is 0. Not going to happen, right? So the alternating series test is inconclusive here, okay? Because an alternating series test, that needs to be 0. However, that points us inconclusive, if I can spell it, That points us to another test. Any thoughts, maybe? Since this limit was not 0, does that make you think of anything? One we haven't talked about in a while yet. What about the test for divergence? Isn't there something there we can use maybe? On the test for divergence, that states if your a sub n, which, on test for divergence, you are looking at the whole picture. You're looking at the a sub n here. The test for divergence says if the a sub n's, the limit as n goes to infinity of your a sub n's is not 0, it's divergent. Well, let's think about that. If we look at the whole thing now, a sub n, negative 1 to the n plus 3n over 4n minus 1, we can't conclusively say what the limit is because what happens? Well, it kind of breaks up into two things, doesn't it? Because on the one hand, on the positive side of it, because you've got positives, then you've got negative terms. Well, on the positive side, wouldn't part of the terms go, the positive terms here are going to go to 3/4. So the positive terms have a limit of 3/4 by this, because that's what we did right here, right? The positive terms. Positive terms have a limit of 3/4. The negative terms have, what would their limit be, you think? Be negative 3/4, wouldn't it? Yeah, because everything, the negative terms, which would be the odd ones. Yeah, the odd ones would be negative. The odd terms are all going to be negative, but just throw a negative on that, and you're just going to get negative 3/4. So part of the terms go to 3/4, part of the terms go to negative 3/4, so it's pretty clear neither ones go to 0. The limit is not 0, so yeah, by test for divergence, this series diverges. So even though it's an alternating series one, in this case we have to go back to the old test for divergence. But again, like I said, once we got to part 2 of the alternating series test, it kind of clued us in to look at that because this limit was not 0. And that falls into the test for divergence. All right. Is that okay? All right. Let's look at another one. What about the series? Negative 1 to the n plus 1 times n squared over n cubed plus 1. Again, it's alternating series, so alternating series test is our first choice. So b sub n here, of course, is the n squared over n cubed plus 1. All right, so part 1 is, we need to talk about it. What is part 1 of the alternating series test? Part 1 says, is b sub n plus 1 less than or equal to b sub n? Well, if I do n plus 1, this is not how we may want to do this. Yeah. May not be the way we want to think of it because you got top and bottom, something changes there. So yeah, this n plus 1 squared, that's obviously going to get bigger. This is going to get bigger too. So I've got bigger divided by bigger. Which one's bigger? I mean, we're squaring, so we're thinking this probably gets less big than this does, but how can we be sure? So this is kind of, yeah, it's kind of, but isn't another way of looking at it, thinking this is wanting to know if you've got f of x equals x squared over x cubed plus 1, isn't that saying, well, is that decrease? We're talking about x being bigger than 1. Isn't this also asking, isn't it asking, is this decreasing starting for x bigger than or equal to 1? Isn't that another way of looking at it? It's basically saying this function is decreasing. I want the b sub n plus 1 terms less than the b sub n. So it's basically asking, is this function decreasing? And the reason I put it in that terms is we know how to get, we can tell something about decreasing on that, can't we? Just by using the first derivative. Low d high minus high d low. It's not a real easy derivative, but it's not too bad. What did I say? Low d high minus high d low over low squared, which looks daunting, but if you simplify it out, that's 2x to the fourth plus 2x minus 3x to the fourth over. Basically, I'm wanting that equal to 0, which means that equals 0, which is 2x minus x to the fourth is equal to 0. That'll put it where my dividing lines are. Factor out an x. So x is 0. That'd be x is the cube root of 2. So it breaks up at 0 and cube root of 2. Well, after cube root of 2, which I could plug in 1, at 1, I'm talking the derivative. What's that derivative at 1? Well, it's it would be 2 minus 1 over 4. That's positive. It's in. Sorry. Did I do that right? I didn't do that right. 2 minus 1. 2 minus 1. What have I got wrong? Should be decreasing. Negative 2. Negative x to the fourth plus 1 over 1. Positive. What am I doing wrong? It should be negative. I got it positive. It should be negative. Low d high minus high d low, low squared. Should be decreasing. Should be negative. Let me look at the graph. Make sure I'm. Maybe it is increasing. I don't think it is, though. Huh? These get smaller. I'd like to show you that. So it should be decreasing. Why is it not? That's what's bothering me. Yeah, because this graph just comes up and it definitely shows there that it bumps up and then starts decreasing. Why is my derivative not showing that? I must said my derivative. Low d high minus ideal. I did that right? It's not the other. Because if it was the other way around, that would fix it. Low d of the high. That's right, right? Okay. So it is decreasing. It turns around here at this cube root of 2, so it goes increasing. Oh, that's what it is. Okay. Aha. Thank you. Thank you. Cube root of 2 is over here. So I need to do 2. There we go. Thank you. Ah, that makes me feel better. All right, so it'd be 4 minus 16. Yeah, that's negative. Over whatever squared. That's negative. So it's decreasing. I knew it should have been. There you go. Okay, so part 2 is we've got decreasing. So what else do we need? Part 2, limit n goes to infinity of b sub n. So we do the n squared over n cubed plus 1. Which is divide by n cubed, the limit as n goes to infinity, 1 over n, 1 plus 1 over n cubed, and that's 0 over 1 plus 0, that is 0. Check, check. So, by alternating series test, this series converges. Okay,